Hello, welcome to this week's problem of the week. For this problem, we're given a rectangular prism V that has the smallest face with a value or with an area of 48, and the largest face with an area 240, and the third face has area x. We want to figure out the sum of all the possible values of the area of x. So the first thing we do is we have a rectangular prism. So there are three sides that determine the areas of the faces. We don't know the lengths, so we will write down just that we have three sides. So we have three sides written down, just labeled S1, S2, and S3. We can also say that since we're given that the smallest face is area 48 and the largest face has area 240, that the sides are going to be different lengths. So we can say that side 1 is less than or equal to side 2, and side 2 is less than or equal to side 3. So now that we've stated which sides are, or how long the sides are in relation to the other sides, we can plug in the fact that we know what the largest and smallest areas are, and express them as product of two sides. The smallest face is 48, so that'll be the product of the two smallest sides, S1 and S2, and the largest face has area 240, and that will be the product of the two largest sides, S2 and S3. So as you can see, we have the smallest side being S1 times S2 equal to 48, and then the largest side, S2 times S3 equal to 240. So now we're going to look at the smallest side first. We have S1 and S2 equal to 48. So now what we're going to do is figure out what possible values S1 and S2 could have. So we're going to express these values in ordered pairs, S1, S2. What we'll be doing is just figuring out ways to factor 48 such that S1 is smaller than S2. And so after doing that, we see that there are 5 possible combinations that fit this criteria. 1 and 48, 2, 24, 3, 16, 4, 12, and 6 and 8. And yep, these both the product of all of these, is 48, and in all of them S1 is smaller than S2. So now we have 5 possible values for S2, 48, 24, 16, 12, and 8. Now we'll plug them into this criteria and see which ones hold. So what we did here is we put in all the values of S2 that we got here, and we see if they would fit here. So we find that all the values of S2 are factors of 240, so we get integer results for all of them. And we see that not all of them will work. We have 48 and 5. We see that S2 is bigger than S3, so this doesn't work. We see the same with 24 and 10, and 16 and 15. We do find that 12, 20, and 8, 30 as values of S2 and S3 do work. So we say these two are good results, and the other ones we can get rid of because they don't fit the criteria. So now we have our possible side lengths of the rectangular prism, 6, 8, and 30 as one combination, and 4, 12, and 20 as the other. And so now for the area of x, we take the value of the smallest side, S1, and multiply it by the value of the longest side, S3. And so we'll do that for each of these prisms, we'll label 6830 as V1 and 41220 as V2. As you can see, for V1 we have 6 times 30, the smallest and biggest side, in the area of x equals 180. For V2, the small side is 4, the largest side is 20. And so we have 80 in the area of the face. So all we have to do is sum 180 and 80 to get our final answer. And so doing that, we see that the sum of all the possible values of x is equal to 260. Thank you so much for watching this week's Problem of the Week. Be sure to subscribe to our YouTube channel, follow us on Facebook and Twitter, and check out our website, centerofmath.org. Thank you.